In this video, I will try to introduce you to the use of functions in Mathematica. Mathematica is equipped with the capability of two different types of functions. Number first, built-in function, and number second, user-defined functions. To benefit from the user-defined function capability of Mathematica, one has to be at a bit higher level in using Mathematica. So presently, I will limit myself only to the use of built-in functions of Mathematica. Most of the built-in functions in Mathematica are complete names of mathematical commands, which usually begins from a capital letter. However, if you are blanked and have no idea how to recall a particular function, there is a built-in help in Mathematica. For that, you just have to press in the F1 key on your keyboard. That will open up another window with a search bar. Write down the name of the particular function, and accordingly you will be guided by the Mathematica. However, there is another very fancy way without going into the help windows, just by writing the sign of interrogation within the notebook followed by the name of that particular function. For example, here I want Mathematica to tell me about the command sum, so I put a sign of interrogation first to the command sum and run it. If I run this out, Mathematica give me a list of different option or command in which the sum command can be used. The first one is sum over f, where f is anything which we want to sum over, and with a list of starting with I and I to maximum. This command in fact evaluates the traditional sum of this form. Similarly, if you want to bound your sum to a particular value, then it starts from, you have to put I minimum to I maximum, and it starts, which means that the sum starts from the index I minimum. And there is another option for the command which gave you di. This di, as the Mathematica says, uses a step. You want to change the value of the index by the step this one, and you can go through the other option as well. In this case, the list over I is called iterator of the sum. There is another way of searching which is called wildcard, and the wildcard can be activated by putting asterisk after the name of the command. If I run this, it gives me a list of all the possible commands that containing the word sum. For example, here I have this thing, some convergence, some summation layer. If I click on any one of them, it will give me all the possible application of this command. So as if I click on this one, I'll get the other list in which some convergence is used, and if I click on this one, it will give me all the possible situation in which I can use some layer. If you run a command on Mathematica and Mathematica reproduce the same input as your result without making any change, that means there is something wrong with your input. You have to recheck your input very carefully. In order to get a deeper insight into using the built-in command, I would like to apply the sum command to different situations. The first one is I want to sum up the value of a function as a square of x, where x varies from 1 to 4. If I run this out, it will give me answer 30. This, in fact, in the traditional way, this thing is in fact equal to 1 square, which is 1 plus 2 square plus 3 square plus 4 square, and that of course gives me 30. Similarly, let me use another command which is built in Mathematica, and that is called product. Product gave us the product of different numbers. For example, if I want to find the product of all the integers starting from 1 to 5, I can write that in this way. And this command means that I'm multiplying all the integers starting from 1 to 5. If I run this one, I'll get the same result, 120. The sum and product commands can be used to compute multiple sums and multiple products. For example, I can sum up with two variables simultaneously. As an example, let me sum over x and y, where x starts from 1 to 4 and y starts from 1 to 6. If I run this command, I'll get 144. If you do that manually, of course, you will get this thing. In fact, this thing corresponds, in the traditional representation of mathematics, this thing corresponds to these double sums, one over x running from 1 to 4 and the other over y running from y to 6 over the function x plus y. The sum and product command was just examples from the too many built-in command in Mathematica. It knows about logarithmic function and all the rules followed by such functions. It also knows about exponentials, square roots, absolutes, and so forth. The exact form of applying such commands are given in the table that you see on the screen. Here, log of x in fact stands for natural logarithm, and log of 10 comma x stands for logarithm to the base 10. And if you want to find out, for example, binary logarithm, then you have to replace this 10 with 2. Similarly, the exponent of a function can be written as exponent of x. The power of a number x raised to the power y can be expressed as power xy. The square root of a function or a number can be found by enclosing that number inside the square brackets of the function capital S, Q, or T. The absolute is implied by this one function. This is the sine function, round off function, floor function. And furthermore, Mathematica know all the rules for and Mathematica knows all the rules of trigonometric function. The trigonometric function can be implied by sine of x, cos of x, tangent of x, and the inverse of these in Mathematica, or employed by arc sine of x, arc cos of x, and arc tangent of x. You see in this list there are almost all the commands bear their traditional mathematical names. However, each of these functions starts from capital letter, and that's what the Mathematica command differentiate from the common usage of these functions. Mathematica knows the values of many mathematical and physical constants. For example, employing the cosine of pi would give you -1. Similarly, operating sine function over pi by 2 will give me 1. Cos inverse of -1 would obviously equal to pi, and Mathematica exactly understand the notation of pi, so it reproduces pi. And or the inverse of sine gave us pi by 2, and Mathematica again understand what pi means. Here, this is another example. If I apply the sine to pi by 4, it should reproduce 1 over square root 2. You see that sine pi by 4 doesn't return the approximate solution such as 0.707. Rather, it gives the exact value square root 2. However, we can turn the kernel of Mathematica into producing approximate result by adding a floating point to the number such as pi by 4.0. If I run this one, Mathematica reproduce the approximate solution, which is 0.707107. The same result can be obtained by putting the numerical command, where the numerical command is implied by capital N. If I run this one, I'll get the same result as I obtained from introducing the floating point. Similarly, if I apply the square root function, Mathematica would return again just the square root. And if I'm interested to find the approximate value of square root function, I have to introduce the floating point. And if I run this one now, I'll get the numerical approximate value. The same result can be obtained like before by putting the numerical command and I'll get 1.41421, which here we obtain by inserting a floating point. So this was a short introduction to using the built-in command. You can search for other command within the help menu or just by using the sign up interrogation like I introduced you in the beginning for some command.